Okay, so the first question we're going to do here, we're going to do the sine rule again, and this is a slightly more challenging one. And the reason why it's more challenging is because we have to do more than just the sine rule. Okay, so it says find the area of this shape corrected 2 decimal places, and there's the question there, the triangle there. They want you to find the area. I've given you the answer, so if you want to work ahead, you can see if you can get the answer yourself. And I've given you a second question to try, so if you've got through this question, then you can go on and try this question, and again, the answer is there again. Okay, so the question is to find the area corrected 2 decimal places for this shape, and the second question is to find the area corrected 2 decimal places for this shape, and I've given you the answers so you can check your answers if you're doing them by yourself, right? Okay, so in order to do this question, okay, so we'll just look at this one first. So in order to do this question, you need to find the area, right? So if you're asked to find the area of a triangle, the first thing you would think of is the area of a triangle is half the base times the perpendicular height. But in this case, we don't have a length for a base, and we don't have a length for a perpendicular height. So we know we're going to have to use trigonometry. Okay? So we know it's going to have to be trigonometry. So the first thing we know about trigonometry, well, if we were going to go on to the area of this triangle, we'll start by looking at the area of this triangle. If we're going to get the area of this triangle, we'd have to get half AB sine C, right? And half AB sine C is where we have an angle and a side either side of that angle. So if we were going to use half AB sine C, we'd be looking at, we've got two sides and we need this angle here. So if we were going to use the area of the triangle, it would have to be half AB sine C, and in that case I have to have two sides and the angle in between. So you can see here that I can't actually get the area of the triangle straight away, that I have to do a few other steps first. Okay, so I need to find out that angle. So how I can find out that angle is I can work through my chain of how I operate, and I'll be able to work out this angle here. So angles in a triangle equal 180 degrees. In this case, that won't help us because I don't know this angle and I don't know this angle, so I wouldn't be able to work out the unknown angle there because there's too many unknowns. Okay, 90-degree triangles is next. There's no 90-degree here, so 90-degree triangles doesn't help. Okay, so I can't use Pythagoras' theorem and I can't use trig ratios. So I can't do either of them. So the next thing that comes up is the area of a triangle. I don't know the area. In fact, I'm trying to find it, so that's of no help to me. So the next thing that comes up is the sine rule, and I'm going to see if I can use the sine rule to find the missing side. So, or missing angle even. In this case, I can use the sine rule because I've got an angle opposite a side, so I compare the two of them together. But the only other ones that I compare together are these two. Okay, so I compare them two together. So let's just have a look there and see what would happen if I did that. So if I was to pair the two of these together, I'll just do that in pen. So if I was to pair the two of these together, and if I was to pair, we'll say, the two of these together, okay, then I would have found out a value for this angle here. Now, if I have a value for this angle and the value for this angle, then I would be able to use the fact that angles in a triangle up to 180 to be able to find this angle. Okay, so I can see how this is one step closer to what I need to do. So I can see that if I was to use the sine rule here and find this angle, then I'd be one step closer to being able to get the size of this angle. And if I could get the size of that angle, I'd be able to get the area of the triangle. Okay, so this is what I was trying to get you to understand. Every topic that we were doing individually, in lessons individually, is great. You need to be able to understand how to do them individually. But you need to, questions that will come up on the leave insert are questions where you need to do 2 or 3 different topics to solve a question. So in this case, so far what we're doing is we're doing the sine rule. So that's what we're doing at the minute. Okay, so the sine rule is the opposite angles. The next thing that we're going to have to do is angles in a triangle adding to 180. And the last thing that we'll have to do is the area of a triangle. Okay, so this is just to get you understanding what's actually happening. When you get a question like this on the leave insert, there is going to be, you're going to have to do a number of these. They're not all, it's not just going to be one of these. You're going to have to do a number of these together, okay? Because that's testing your problem solving capabilities, right? So back to what we were doing. We were looking at the sine rule, and we were looking at the opposite side and opposite angles, and we're hoping to find this angle, which we should be able to do. And once we find that angle, then we'll find this angle. Once we find this angle, then we'll get the area of the triangle. Okay, so that brings us on to the sine rule. So what we'll do there is we'll just bring on the sine rule there. So we decided that we're going to use the sine rule. So we'll get straight in there and use the sine rule here and work out what the unknown angle is here. I'm just going to call that unknown angle, for the sake of this, I'm going to call that x. Okay. So the sine rule says that a over sine a, so a over sine a is equal to b over sine b. Okay, so we know what the sine rule is. Now what we're going to do is just going to fill in the information. So from dealing with the sine rule in the past, I've said to you that I always like to keep my unknowns in the first fraction. So totally up to you, but I would advise you to keep your unknowns in the first fraction. So in this case, we'll do the red ones first because the unknowns are in the red one. So we can say the side, which is 11, over sine of the angle, which in this case is sine of x, is equal to the green ones, which is the side 5 over sine of the angle over sine of 21. So it'll be 5 over sine of 21. Okay, so at this stage we have a fraction equals a fraction. When you have a fraction equals a fraction, in order to get rid of it, all you need to do is cross multiply. So I'm going to cross multiply here. I'll multiply the two of these together. Okay, and I'll multiply the two of these together. Again, we have an unknown here. The rest, we have a number, and this represents a number. So the unknown is the denominator of the first fraction. So like I said to you, I like to keep the unknowns on the left-hand side of the equation. So what I'm going to do is I'm going to multiply the two of them and keep them on the left. So I multiply the pink ones and say 5 sine of x is equal to 11 sine of 21. So all I've done is I've cross multiplied. I multiplied the two of them together to get 5 sine of x, and I multiplied the two of them together to get 11 sine 21. Okay. I'm just going to see there, my goal is to find out what x is equal to. So I'm just going to highlight this here so that I can make some observations. So I want to get x by itself. You can see here what I'm doing. I'm multiplying 5 by sine of x. So if I want x by itself, I'll need to get sine of x by itself first. So I want to get sine of x by itself first. And if I got sine of x by itself, I'd need to work out what this is. So here I'm multiplying 5 by sine of x. So to get rid of that 5, I need to divide the left-hand side by 5. If I divide this side by 5, I'd be left with just sine x. But because I'm dividing the left-hand side by 5, I have to divide the right-hand side by 5. So I'm going to take that there and I'm going to multiply it by, or divide it by 5. Okay. Bring that down just a tiny bit. Okay. The last step is to get x by itself. So to get x by itself, I need x is equal to. I need to have a look here and see. So if I want x by itself, you can see there that I've got sine of x, but I don't want sine of x, I just want x. So here, what I'm doing here is I'm getting the sine of x, and the opposite to getting the sine of x is getting the inverse. So sine inverse of everything that we had there, which was 11 sine 21 all over 5. I'm just going to put that in brackets. So that will tell us what x is equal to. So in our last step, in order to find x will be equal to, so we just put the calculator up there, and we can see that we need to type in there that x is equal to sine inverse, and we need to type all this into the calculator. So I'm just going to type that in here to the calculator. So we can start by turning on the calculator. Okay, make sure your calculator is in degrees. If you're unsure whether or not your calculator is in degrees, just press shift and mode and press 3 to get into degrees. Okay, so we need to type sine inverse. So we need to type sine inverse into our calculator, and to get sine inverse, you can see there sine inverse is this one here. It's the yellow right in there above the sine. So if you press shift first and then press sine, that gives you sine inverse. Okay, we then need to type in this fraction here. So we're going to press the fraction button because we know it's a fraction, and we're going to press 11 sine 21, close our brackets, and go down to our denominator, and we're going to type in our denominator there, which is 5. We need to come out there and close the brackets, the big brackets. So that's correctly typed in. You can see there sine inverse, 11 sine 21, 11 sine 21 all over 5. So press your equals button and you'll get your answer. So your answer there is 52.0371. Okay, so if we're going to round that to the nearest decimal place, the answer would be 52 degrees. Okay, so 52 degrees. So again, when we're rounding that correct to the nearest decimal place, we're looking at the decimal place. We're looking at the number that follows, which in this case is 0. So because that's 0, the 52 just rounds off. Okay, so I'm just going to bring that out, and we'll try the next part of the question. Okay, so far we found out what x is equal to. So we found out what x is equal to. So we know there that x is equal to 52 degrees. I'm just going to put in 52 degrees. So at the minute, what we know is we know what this is 21 degrees. This is 52 degrees. So we need to be able to find out what. We'll call this one up here, and we'll call that y. Okay. So we know that angles in a triangle sum to 180 degrees. So it was one of the first things we looked at. Angles in a triangle sum to 180 degrees. So we know that. So we're going to use that to help us here. So if I was to add this, which is y, plus 52 plus 21, it should equal 180. So that's what we're going to do. So if I just draw a line there so that we can keep this tidy. Okay. So angles in a triangle sum to 180. So y plus 52 plus 21 equal 180 degrees. So 52 plus 21 gives you 72. So y plus 72 is equal to 180. So y will be equal to 180 minus 72. So 180 take away 72 leaves you with 108. Okay, so I know there that y is equal to 108. Okay, so that brings me to the last part of the question, which asks me to find the area of the triangle. So the area of the triangle, we know that the area of a triangle is half AB sine C. Okay, so the area of a triangle is half AB sine C. I need to go back and look. It's important that when I get in the area of a triangle that I have a side, angle, side. And in this case, I have side, angle, side. What I mean by that is you can't just take this side, and this angle. You can't just take this side, and this angle. They have to be in the shape of a V. So you have to have a side, angle, side. Okay, so they have to be connected. They have to be, you have to have a side running into an angle and coming out a side at the other side. Okay, so it's very, very important that you realize that you can't, they have to be side, angle, side. You can't say side, side, angle. That wouldn't work. Okay, so in this case, obviously C will be equal to 108. Okay, so I'll just put that in there in maybe slightly bigger writing. So C is 108. So C is this one. A is obviously A, and B is obviously B. Okay, so we can fill those values in. And if we fill those values in, we'll get half of 5 times 11. So half of 5 times 11. Half of 5 times 11 times sine of the angle, which we worked out to be 108. I'm just going to show you how we type that into our calculator. So just type that in. What we need to do when we're typing that in is we need to clear our calculator. So press the AC to alt here. We need to put in half. So put in your fraction, 1 over 2. Multiply that by 5. Multiply that by 11. And multiply that by sine 108. Close your brackets and press equals. And you can see there the answer is 26.154 and so on. They asked us to give it 2 decimal places, so we'll do that. So the answer there will be 26.1540542. So the final answer to 2 decimal places is go back 1, go back 2, draw your line. We look at this number. So the final answer will be 26.15 centimeters squared. Okay.